Hi guys. Welcome back. So today's lesson, quote unquote, like I think I said this last week. It's not really any new material. Just kind of going over some of the things we've been talking about last week, sections 5.1 and 5.2, perpendicular bisectors, angle bisectors, medians, altitudes, all that fun stuff. And I know this says quiz, and I know I posted something on Classroom that said we're not really, it's not as high stakes in terms of quiz as you're used to, but I had this printed out before I made that post. So, sorry. But yeah. So just a quick refresher of the kinds of things that we talked about over the past few days. I hope this isn't going to be too long. Question number 1 is asking you to find the length of WZ. So how can we go about that in the context of this picture? Well, because we have the right angle here and these two tick marks, perpendicular, midpoint, we know WX is the perpendicular bisector of ZY then. So what that means is if you have this point, any point on the actual perpendicular bisector is going to be equidistant from the two endpoints of the segment. That's what the perpendicular bisector theorem says. So, in regards to this problem, how would we figure this out? Well, what we could say then is that WZ is congruent to WY. So that means we are able to take those two expressions and set them equal to each other. And then solve. So 2x is 16, x is 8. Plug that back into 2x plus 11, so that's 16 plus 11 is 27. And as usual with stuff like this, if you plug it back into WY, because you know that they're equal, you should get, there we go. You should get exactly the same thing regardless of which expression you plug it into because you know that they're both equal to each other. And that's the whole thing for example number 1. Okay. Example 2 is different because it's talking about a different kind of segment. All right. With all of these tick marks on each of the pieces of the sides of the triangle, you know that they're being bisected, but you don't have any right angles here, so you can't say that they're perpendicular bisectors. What you know is that they're medians, all right? Or what you can say is that they're medians. Because medians, again, by definition, pass through one vertex and the midpoint of the opposite side, all right? So we're dealing with a whole bunch of median stuff, centroids, all that fun thing, all those fun things. So let's see. VU is 2. PV, which is this, is 12, and RS, this whole thing is 9. So, all right. I think, well, deals with the idea of the centroid theorem, which says that the distance from the vertex of the triangle to the centroid is 2/3 of the distance, or is 2/3 of the length of the median. So I think that one's actually easiest to find first, because RV, I just pointed it out, is that exact distance. The distance from the vertex to the centroid, it's 2/3 of the median. So RV is 2/3 of RS, which is 9. So if you just do that math real quick, RV is 6. All right? So, QV and VT are a little bit different, all right? So we'll go with QV first, all right? So we know that QV, because it's the distance from the vertex to the centroid, is 2/3 of the length of QU, which we don't know. We know the length of VU. What we could also say is that VU is the remaining part. So if QV is 2/3, VU is going to be 1/3, all right? The problem is then we're finding the relationship. We have to figure out a relationship between VU and QV, all right? So we're trying to compare like the scale factors, 2/3 to 1/3 or 1/3 to 2/3. And how do those two numbers compare? Well, if you're comparing 1/3 and 2/3, 2/3 is 1/3 times 2. You know, if you did that math in your calculator really quick, 1/3 doubled is going to be 2/3. So the relationship between these two pieces of the segment, you might have had a question like this on your homework, whatever day you did this, I think it was Thursday, that asked you to find these certain scale factors. So QV is going to be double VU, which you don't even need to really set up an equation to figure that out. You know what 2 times 2 is, it's 4. VT, though, is in the opposite. I'll put that here, too. VT, though, is in the opposite direction. You're given PV, which is the 2/3 piece. So VT is the 1/3 piece, and 1/3 is half of 2/3. So VT is going to be half of 12. This is 6. This is 6. All right. And that's example number 2. Okay. Medians, we just said, pass through the opposite vertex, and it also passes through the midpoint of the opposite side. All right, so if we're writing the equation of the median from vertex A, this point A is going to be one of the two that we're going to use to write the equation. All right, so it's got to pass through point A and the midpoint of the other side. So that other side here is BC. So the first thing we got to do is find the midpoint of BC. I think we all hopefully know the midpoint formula by now. So this is 6/2, which is 3, and 2/2, which is 1. All right. So the line has to pass through these 2 points. All right. Point A and this midpoint of BC. So it's these 2 points that we're going to take the slope of. All right. 1 minus 2 over 3 plus 4, and that's -1/7. That's our slope. All right? And so we're using this slope, -1/7, and it really doesn't matter which point you pick, when you're writing the equation of a line. That's the Algebra 1 stuff. So I'm going to go with 3, 1, just because I think the numbers are a little bit nicer. Someone asked me, because I remember in the 5.2 lesson video that I did, somebody was asking me, do we have to use point slope form to write the equation of a line? No. If you're more comfortable using slope intercept form the entire time, that's fine. All right, so I'll do that for you guys' sake. 1 is equal to -1/7 times 3 plus b. Definitely looks like you're going to get a fraction here. That's -3/7 plus b. So 1 is 7/7. You add 3/7 to both sides, so that's 10/7. That's your y-intercept, which means the equation is -1/7 x plus 10/7. And there you go. Not a big deal if you get fractions. This is level 1. You should be used to them by now. There you go. Okay. So, perpendicular bisector is more, there's more requirements that go into it. We talked about it a couple problems ago. It's got to be perpendicular and it's got to pass through the midpoint. So if we're talking about the perpendicular bisector of BC, you are going to have to find the midpoint of BC at some point. I'm going to do that first. Are these the same points? Oh, these are the same points, I think. Yeah. These are the exact same points. So the midpoint is exactly the same as the last problem. All right, sweet. But perpendicular, so we got the bisector part of it. That's one of the points that we're going to have to use. And then the other part of it comes in perpendicular. We know perpendicular when talking about lines, opposite reciprocal slopes. All right, so perpendicular bisector of BC, it's got to be the opposite reciprocal slope of BC. All right, which I don't think we did that part in the last problem. All right, so we're going to find the slope of BC. So that's -4 minus 6 over 1 minus 5, -10 over -4. So that reduces to 5/2. That's the slope of BC. But again, opposite reciprocal. So the slope that we're actually using to write the equation of this line is -2/5. And then we do exactly the same thing that we did before. We have this point, we have this slope. I feel like we're going to get a fraction again, and then we can just use slope-intercept form to do it. So that is negative 6 over 5. 1 can be rewritten as 5 over 5 with that common denominator. So 5 over 5 plus 6 over 5 is 11 over 5. So the equation of the line, we'll do it down here, is negative 2/5 x plus 11/5. Okay. All right. Altitude is different. All right. Similar sort with medians, in the sense that it's got to pass through the opposite vertex of whatever segment you're talking about. But altitudes are only perpendicular. They don't bisect. All right. So if we're asked to find the altitude of AC, we're going to need that opposite reciprocal slope of AC, which again, I don't think we've had to do yet. So the slope of AC is 1 plus, no, that's not it. I'm doing midpoint. Y over X. So negative 4 minus 2 over 1 plus 4 is negative 6 over 5. Okay? So perpendicular, again, opposite reciprocal. The slope we're using is positive 5 over 6. And again, I said this already, it's got to pass through that opposite point or the opposite vertex of the triangle. So we're writing the equation of the line with this slope that passes through this point. All right. So a little bit less work, I think, than the last couple problems, but we're still going right into slope-intercept form and stuff. So 6 equals 5 over 6 times 5 plus b. That's 25 over 6. So let's actually use a calculator for this one. 6 minus 25 over 6 is 1 5/6. Okay. And then I'm going to use this button up here to convert that to an improper fraction, 11 over 6. Sweet. So the y-intercept is 11 over 6, which means the equation is y equals 5 over 6x plus 11 over 6. Ooh, a lot of fractions. Again, shouldn't be a big deal considering this is a level 1 course. Okay? Okay. No. Skip one. There we go. All right. So let's see. Given that the measure of angle PCB is m squared and the measure of angle ACP is 6m minus 8, find the measure of the entirety of ACB. All right. So looking at this picture here, if this is what you got, you have these distances to this point being congruent and also being perpendicular to the sides of the giant angle. All right. So what that means in the context, what that means is that you've got you have an angle bisector here. Okay. So that means ACP is congruent to PCB, which means you can set these two equal to each other. And there you go. It's only complicated because, as I think you guys might have been able to figure out, you are going to have to factor. M squared minus 6m plus 8 is 0. What are factors of 8 that add up to negative 6? Negative 4 and negative 2. So m is 4 and 2. All right, so they're both positive, which means you are able to plug them both back in. And you will get answers that make sense at the end. But the thing you have to be careful about is that you're finding ACB. All right. So like it doesn't really matter where you plug them in originally because you know these two expressions were equal to each other. I think this one's way easier. If you plug in 4 squared, you get 16. And if you plug in 2 squared, you get 4. But that would get you PCB, right? Which is only half of the angle that you're looking for, ACB. So if you get 4 squared is 16, ACB is double 16. So one possibility is 32 degrees. Another possibility would be double 4, which is 8. Okay? Is this the last one? This might be the last one. All right. Segment MT is a median. Find X. All right. We will start with that. All right. If MT is a median, that means AH is being bisected. All right. So AT is congruent to TH, which again, I think this is one of the first problems we did today. These two expressions, you can set equal to each other. Excuse me. So X is 4. Cool. Decide whether or not MT is also an altitude. All right. So we just talked about altitudes a couple of problems ago. With altitudes, you have perpendicular segments and which means you have right angles. All right. So if MT formed a right angle with AH, that is how you would be able to say whether or not it's an altitude. If this angle is 90 degrees, then it is an altitude. And if it's not, it's not. All right. So because we have an expression to represent the measure of angle MTH, we can easily plug our X value in and figure this out. All right. So the measure of angle MTH is 23 times 4, which is 92 degrees. It's not a right angle, so it's not an altitude. All right, so an explanation I would be totally fine with is something like, no, angle MTH is not a right angle. Okay, nothing more than that. All right, so again, I said this in my big long post that I made on Saturday. I don't want you guys to stress over this and like freak out like I know you guys normally have a tendency to do before quizzes and tests and stuff. This is really just to make sure that you guys have a good understanding of 5-1, 5-2, perpendicular bisectors, angle bisectors, medians, altitudes, all that fun stuff. But definitely reach out if you need. Lots of places. I went through in that whole post, lots of places and resources that you can use on when and where you can find me. And I'm here for you. All right. That's my goal for these next several weeks, is really just to like be here for you. You know what I mean? All right. So, good luck out there, guys. Stay safe. I'll talk to you soon.